Dear students, in the previous lecture I have discussed different types of forecasting errors. In this lecture I am going to discuss about 3 forecasting techniques. One is moving average method, second one is weighted moving averages method, and the third one is exponential smoothing. For the exponential smoothing method I am going to cover only introduction. In the next lecture I will cover in detail about exponential smoothing. So, the agenda for this lecture is moving averages, weighted moving averages and exponential smoothing. So, in this lecture we discuss 3 forecasting methods that are appropriate for time series with horizontal pattern, that are moving averages, weighted moving averages and exponential smoothing. These methods are also capable of adapting well to changes in the level of a horizontal pattern, such as what we saw with the extended gasoline sales time series. So, whenever the data follow a level, whenever there is a horizontal pattern is there, horizontal pattern means need not be exactly straight line, it may be like this. Then this moving average method, weighted moving average and exponential smoothing method are more suitable. However, without modification they are not appropriate when considerable trend, cyclical, seasonal effect are present. So, another drawback of this moving average and exponential smoothing method is if there is any trend. So, this method cannot be used as it is, we need to have certain modifications, because the objective of each of these methods is to smooth out random fluctuation in the time series. They are referred to as smoothing methods. Actually here these methods are helping to smooth out the random fluctuations. If there is any trend, this method is not suitable. These methods are also easy to use and generally provide a high level of accuracy for short range forecast, such as forecast for the next time period. So, first we will discuss about moving averages. The moving averages method uses the average of the most recent k data values in the time series as the forecast for the next period. Mathematically, a moving average forecast of order k is as follows. So, the forecast value for t plus 1 equal to sum of most recent k data values divided by k. So, sigma of I equal to t minus k plus 1 up to t for yi. So, here yii means y t minus k plus 1 plus and so on plus y t minus 1 plus y t upon k, where y cap t plus 1 is the forecast time series for the period t plus 1, yi is the actual value for the time series in period I, k is number of periods of time series data used to generate the forecast. So, how this formula exactly used I will explain you with the help of an example in coming slides. The term moving is used because every time a new observation becomes available for the time series, it replaces the oldest observation in the equation and a new average is computed. So, the average is moving, that is why it is called the moving average method. Thus, the period over which the average is calculated change or move with the each ensuing period. So, with the help of example I will explain the concept of moving averages. To illustrate the moving averages method, let us return to our original 12 weeks of gasoline sales data, which I have explained in the previous slide. That data also given in this lecture, in this presentation. So, the time series plot for the given data indicates that the gasoline sales time series has a horizontal pattern. You see that when I plot, see that there is a horizontal pattern is there. There are slight fluctuation, but the total effect is only a horizontal pattern. Thus, smoothing methods of this moving averages is more suitable for this kind of data. To use moving averages to forecast a time series, we must First select the order k or the number of time series value to be included in the moving averages. That is the meaning of k. In our formula also, the k is the number of time series values to be included in the moving average. If I say k equal to 3, the last 3 values will be used for finding forecasting for the next period. If only the most recent values of the time series are considered relevant, a small value of k is preferred. If you find in the given data set you want to consider only the most recent values, then we have to choose the value of k is very small. If the greater number of past values are considered relevant, then we generally opt for a larger value of k. As mentioned earlier, the time series with a horizontal pattern can shift to a new level over time. In that case, the moving average is not suitable. What is the meaning of that? Suppose the level is like this. If there is a slight shift, then this moving average method cannot be used as it is, some modifications required. A moving average will adapt to the new level of series and resume providing good forecast in k periods. Thus, a smaller value of k will track shift in time series more quickly. The naive approach discussed earlier is actually a moving average for the k1. Remember, in the first presentation of the forecasting techniques, I have explained the naive approach, that is nothing but the moving average where k equal to 1. On the other hand, larger values of k will be more effective in smoothing out random fluctuations. When you increase the k value, it will become more smooth. That is why choosing the right k is most important. Thus, the managerial judgment based on understanding of the behavior of a time series is helpful in choosing appropriate value of k. If the k is higher, for example, I will plot it. Suppose this is k equal to say 5. If you choose smaller value of k, for example k equal to 2 like this. So, what will happen when you choose higher value of k, it will become flat, okay, the line will look like a flat. To illustrate how moving average can be used to forecast gasoline sales, we will use 3-week moving average period. So, what is the meaning of the 3-week? Look at the table which is given on the right hand side. First you will take 3 values, then find the average, that will be the forecast for the 4th period. The next one, this period, last 3, that will be the forecasted value for the 5th period. Okay. So, like this we will continue. So, I will explain exactly what is happening in this methodology. We begin by computing the forecast for sales in week 4. Suppose I want to forecast, I have the actual value 23. So, Y4 the average of week 1 to 3, what will happen? 17, 21 and 19. So, when you find by 3, because it is a 3 period moving average, so it is 19. So, this 19 is the forecasted value for week 4. Thus, the moving average forecast in sales week 4 is 19 or 19,000 gallons of gasoline. Because the actual value observed in week 4 is 23, the forecast error in week 4 is, we know that what is the error? Actual minus predicted. So, actual is 23, predicted is 19, the difference is 4. Similarly, if I want to forecast for the 5th week, so last 3, that is 21, 29, 23 upon 3, that will provide the 21. So, this 21 is the week 5 forecast. Hence, the forecast of sales in week 5 is 21 and the error associated with this forecast is actual minus predicted 18 minus 21, that is minus 3. A complete summary of 3-week moving average forecast for the gasoline sales time series provided in the table. A complete summary of 3-week moving average forecast for the gasoline sales time series is provided in the table, which is available in the next slide. Now, look at the right hand side. This figure shows the original time series plot and 3-week moving average forecast. Note that the red line show how the graph of the moving average forecast has has tended to smooth out the random fluctuation in the time series. When you increase, instead of k equal to 3 or k equal to 4, it will become more smoothened. Now this is the complete table which says about which shows about the 3 period moving average. So we have actual value is there, here there is a forecast is there, then error, then absolute value of forecast error, then the squared forecast error, then percentage error. What is a percentage error? Error, for example, this is 4 upon 23, that is called percentage error, then the absolute value of percentage error. So these values will be used. For example, this is a total of absolute value of forecast error. When you divide by this 24 upon 9, because these values only we have the error. So we will get mean absolute error. Then when you divide this 92 by 11, you will get mean squared error. Then when you divide by 129, you will get mean absolute percentage error. So now for the 3 period moving averages, let us discuss about forecast accuracy. In the previous lectures, we discussed 3 measures of forecast accuracy: mean absolute error, mean squared error and mean absolute percentage error. So using 3 weeks moving average calculation table, the values of these 3 measures of forecast accuracy are: for mean absolute error, this is 2.66, mean squared error 10.22, mean absolute percentage error is 14.35. In our previous lecture, we showed that using most recent observation as the forecast for the next week, that is a moving average of k equal to 1, that resulted in value of mean absolute error is 3.73, mean squared error is 16.27, mean absolute percentage error is 19.24 percentage. Thus, in each case of the 3 week moving average approach has provided more accurate forecast than simply using the most recent observations as the forecast. So when we compare to a naive method where k equal to 1, when you increase k equal to 3, so the accuracy of our forecasting method has increased. Also note how the formulas for the mean absolute error, mean squared error and mean absolute percentage error reflect that use of a 3 week moving average leaves us with insufficient data to generate forecast for first 3 weeks, because first 3 weeks we are not able to find the forecast. So first 3 out of 12 data set, first 3 data set will not be considered for finding the mean, only 9 data set will be considered. To determine if a moving average with a different order k can provide more accurate forecast, we recommend using trial and error to determine the level of k that minimizes the mean squared error. Many times this will be an obvious doubt, what should be the right value of k? So what we have to do for the same problem, we have to use different k value. For each k value you have to find out mean squared error. For what value of k you are having lesser mean squared error, so that k is the most appropriate. For the gasoline sales time series, it can be shown that the minimum value of mean squared error corresponds to a moving average of order k equal to 6. So when we have done so far k equal to 3, suppose when you put k equal to 6, so we will get more accurate value. If you are willing to assume that the order of the moving average that is best for the historical data will also be the best for future values of the time series, the most accurate moving average forecast for gasoline sales can be obtained using a moving average of order k equal to 6. Here it is assumption is if you want to forecast. So we have seen 12 weeks pattern. In the future weeks also, if you assume that the same type of pattern is going to be followed, then this moving average method is most accurate method. Next we will go for weighted moving averages. In the moving average method, each observation in the moving average calculation receives equal weight. That was one of the disadvantages of this moving average. To overcome that, we are going to provide different weight for the past data. So, one variation when compared to simple moving average method is weighted moving averages. That involves selecting a different weight for each data value in the moving average and then computing a weighted averages of the most recent k values as a forecast. So, the formula is, here we are giving different weight. So, the formula for weighted moving average is y hat t plus 1 equal to Wt, that is the weight for Yt actual value, plus Wt minus 1 for Yt minus 1 and so on up to the last value. Here the sum of the weight should be 1. Weighted moving averages, generally the most recent observations receive the largest weight and the weight decreases with the relative age of data values. Suppose if you are doing 3 period moving average method, the most recent value is 19. So, 19, that is week 3 data, will get the weightage 3 by 6. The second week data will get 2 upon 6, this is 1 upon 6, that I have given some values, but the recent value will have the higher weightage. Using the weighted average, the forecast for week 4 is 1 upon 16 into 17 plus 2 upon 6 into 21 plus 3 upon 16 into 19, so 19.33. Note that the sum of the weight is equal to 1 for the weighted moving average method. How to find the accuracy for a weighted moving averages? To use the weighted moving averages method, we must first select the number of data values to be included in the weighted moving averages and then choose the weight for each of these data values. So, we have to find out k, then you have to decide how much weight has to be given for each data set. In general, if we believe that the recent past is better predictor of the future than the distant past, larger value should be given to the more recent observations. In our example problem also, we have done the same thing. For the recent data, we have given the higher weightage. However, when the time series is highly variable, selecting approximately equal weight for the data values may be preferable. The only requirement in selecting the weight are that they may be non-negative and their sum must be equal to 1. To determine whether one particular combination of number of data values and the weight provide a more accurate forecast than another combination, we recommend as usual using mean squared error as the measure of forecasting accuracy. So, we can change the values of k and you can change the weightage. For different set of k and weightages, then you have to find out the mean squared error. Okay. So, for what value of k and the weightage when the mean squared error is lesser, so that is more accurate method. That is, if we assume that the combination that is best for the past will also be the best for the future, we should use the combination of number of data values and the weight that minimized mean square error for the historical time series to forecast next value in the time series. The third method which I am going to discuss in this lecture is exponential smoothing. Exponential smoothing also uses a weighted average of past time series values as a forecast. It is a special case of the weighted moving averages method in which we select only one weight, that is the weight for the most recent observations. The weight for the other data values are computed automatically and become smaller as the observations move farther into the past. So, that weight we are going to consider as alpha, another name is smoothing constant. So, the model for exponential smoothing is y hat t plus 1 equal to alpha into y t plus 1 minus alpha into y t cap. So, if you want to know forecast for the next period, so the previous period actual forecast and it is alpha 1 minus alpha multiplied by the previous period forecasted values. The value of alpha should be between 0 and 1. The above equation shows that the forecast for period t plus 1 is a weighted average of the actual values in period t and the forecast for period t. So, we are taking two consider, one is the actual value which has the weight alpha and the forecast value which has the weight of 1 minus alpha. The weight given to the actual value in period t is the smoothing constant alpha and the weight given to the forecast in period t is 1 minus alpha. It turns out that the exponential smoothing forecast for any period is actually a weighted average of all of previous actual values of the time series. In coming slides I will explain how the value of alpha decreases. Let us illustrate by working with a time series involving only 3 periods of data y1, y2, y3. To initiate the calculation, we let y hat equal to the actual value of the time series in period 1. So, we assume that the forecasted value for y period 1 is the actual value. Hence, the forecast error for period 2 is y2 hat alpha into y1 plus 1 minus alpha y hat 1. The y1 is the actual, y hat 1 is the forecasted value for previous one. So, that is nothing but your y1. We see that the exponential smoothing forecast for period 2 is equal to the actual value of time series in period 1. Similarly, when you extend that expression for period 3, that is alpha into y2 1 minus alpha into y2 hat. Instead of y2 hat you can substitute y1. Finally, substituting this expression y3 hat into the expression for y4 hat, we obtain alpha into y3 plus 1 minus alpha multiplied by y3 hat. When you substitute this value for y3 hat, so it will become alpha into y2 plus 1 minus alpha into y1. When you simplify this, you will be getting alpha into y3, alpha into 1 minus alpha. So, alpha y3 plus alpha into 1 minus alpha into y2 plus 1 minus alpha whole square into y1. When you extend this one for the fourth period, alpha into y3 plus 1 minus alpha into y3 hat. So, instead of y3 hat you can substitute alpha y2 plus 1 minus alpha y1. When you simplify you will be getting alpha into y3 plus alpha into 1 minus alpha y2 plus 1 minus alpha whole square y1. We now see that y4 hat is the weighted average of first 3 time series values like alpha, alpha into 1 minus alpha and 1 minus alpha whole square. The sum of these coefficient are weight y1, y2 and y3 is equal to 1. A similar argument can be made to show that in general any forecast y hat t plus 1 is a weighted average of all the t previous time series values. Here I am going to explain the behavior of the alpha smoothing constant. Look at the picture on the right hand side. Suppose I have taken alpha value equal to 0.2. So, what will happen? Year 1 it is 0.2, year 2 0.16, year 3 see that the value of alpha decreases exponentially. That is why this method is called exponential smoothing. And you see when we take the smaller value of alpha, it is considering all 11 values years data. So, what is happening? 8th year, 9th year, 10th year the weightage is very less. But you see the example, suppose if I taken higher value of alpha. So, what will happen? It is taken for first 4 previous data set, it has taken more values. Beyond that, for example 5th year, 6th year, almost the weight is 0. So, this is how the exponential curve or the weightage for alpha decreases for smaller value of alpha and the larger value of the alpha. If you choose smaller value, the weight is spread across all the data, all the years. If you take higher value of alpha, most of the weights are consumed only for the 2-3 previous years. Beyond that, it is almost the weights are 0. We will discuss the exponential smoothing with an example in the next lecture. We will also discuss briefly about its forecast accuracy and how it holds up in comparison to other method. Dear students, in this lecture I have discussed 3 forecasting techniques. One is moving average method, then second one is weighted moving average method, third one I have given an introduction for exponential smoothing, then I have explained how the behavior of the smoothing constant. In the next lecture we will continue with the example problem using exponential smoothing, and also I will explain how to use regression analysis for trend forecasting. Thank you.